we are going to go over what we talked about on Tuesday, mainly regarding for loops. I'm not going to talk about while loops too much more, but there are a couple new things I want to talk about for loops, so I just wanted to go through what we talked about on Tuesday and make sure that we're on the same page quick. So in that regard, I just want to review this too. We're going to look at one for loop example regarding some even and odd stuff. So just remember to find if a number is even, we specify a variable that we say mod 2 equals 0. And since there's no remainder, the number is perfectly divisible by 2 and therefore is even. If we wanted to check and see if a number was odd, we just change this equality to be a not equal to. So if we take a number, divide it by 0, and the remainder is not equal to 0, then that number is odd. And we can find any other, we can check and see if any other number is divisible by any other number. We can just specify a number on the left and a number on the right. And if the number on the left is divisible by the number on the right, the remainder will be 0. So I'm just going to go through this example. So we're going to use a for loop to print even numbers from 0 to n. So we will prompt the user, enter n. Then we will okay, so I'm going to restructure this a little bit. We'll have two variables. We'll have I and end. So we will read into n with our scanf. And then we will start with our for loop. So we'll say for I equals 0, so I is going to be our index variable in our for loop. So from 0, we're going to say I is less than n. So we're going to, this for loop is going to run for all I less than n, or for all I that are less, or n minus 1. So if we have specified 10, let's say I equals 10 right here, we're going to run 0, 1, I'll just type it out, 2, 3, 4, 5, 6, 7, 8, 9, but not 10, since we're using less than. If we wanted to go 0 through 10, we need to change this less than to be a less than or equal to. But for this example, let's say we're going to just say less than 10. We're not going to say less than or equal to. So then we'll increment I. So one thing that's worth noting is that we can nest for loops inside of other for loops. We can nest if statements inside of for loops. We can nest for statements inside of if statements if we want to. Any statement that we can specify in our main level of code, we can nest that one level deeper. So we can put an if statement inside this code and say if I mod 2 equals 0, so we're going to test and see if it's even, and we will print out %i is even, and then we'll specify that we want to print I, and then we will say else print out %i is not even, or I should say is odd. And we close off our main function here, turn 0 at the end. Messed up a little bit here, left off my variable that I wanted to increment. So we'll say from 10, so it'll say 0 is even, off and on and off and on, because every other number would be even. Let's say we specified a higher limit, we could say 20 or something like that. And based on the code that we've written inside that for loop, I will be incremented every single time up until it's less than n that we specified. So we specified this 20 here. So the for loop is going to continuously increment I by 1 every single time until we get to I equal to 19, and then the next time around, so let's do this too. So just remember that the execution of the for loop is we increment our variable right at the end here. So right here, after the statements inside our for loop have finished executing, we increment our variable that's specified right over here, right here. And then we do the test right afterwards. And if the test fails, we keep the value of I the same. So just to show you what is actually happening here a little bit better, we'll say I is finally and then we'll print out I. So we can see that the final time through our code, like I was actually incremented all the way to 10, but since 10 would be, since the I that we specified is, the condition at least is not true, so I is not less than n, we're going to not print out this final condition, and our for loop is going to stop executing. So that's just a little bit more about that. So yeah, any other stuff you want me to cover with for loops before we move on to talking about some more advanced stuff? All right. So with that, so just keep the execution order in mind. We're going to initialize the variables, test the condition, execute the block of code, increment the index, and continue back to 2 or go back to 6 if the condition is false. So one thing about for loops is the individual components are optional, so you don't have to specify any of these components if you don't want to. If, for instance, you wanted to leave off the initialization component of the for loop, you could just say semicolon, and this would be where the initialization would go, and nothing would happen. Same with the conditional. You could leave that off if you wanted to. You could say 2 semicolons. So this line right here, there should be an initialization statement here and a conditional statement here. But since those are optional, we can just leave those off. And the same goes for the increment step. We could say for : and it would run forever based on the knowledge that you have right now. But it's completely valid if we wanted to do that. So one of the things with the in-class assignment on Tuesday is ideally how I wanted you to approach that problem is set I equal to x and then increment I. But doing it this way, you could actually leave off that declaration of I and just increment x every single time. So I actually forgot to do that. I just wanted to go over the in-class assignment from Tuesday. I should have done that earlier, but we'll do it now. So for that, I wanted you to read in x and y and then print all numbers between x and y. So we need int x, we need int y, and we'll use int I for our index right now. So leave off the prompts, don't really care right now. We will read x, read y. And then our for statement, we say I is equal to x, I is less than y, and then increment I. So we will print %i, and return 0 at the end. 1020. And that almost gets us there, but can anybody tell me what I need to change to get that to actually print all the way from 10 to 20? Yep, just change this less than to a less than or equal to. To recompile it again. So, and that should work for any other number too. Let's say we specify 0 and 10, or let's say 0 through 20 or anything like that. It'll run no matter what our inputs will be. And that's really the reason we use for loops, because they're completely dependent on the user input. They're not dependent on any of the things that we hard code into the program. So, talking like we did today, we're going to talk about this optional components of the for loops. So we can leave off this first component if we wanted to. So there would be no initialization of I, so we're just going to completely get rid of I. And we're going to go back here, change this to an X, change this to an X, and change this to an X. So we won't have that intermediary variable anymore. And that still works perfectly fine. Now the only reason you'd really want to use an I is if you needed to preserve this X for later use. So if you had a for loop that, let's say, this for loop right here was going from X to Y, let's say you had another for loop which was going from Y to X. So obviously you need to preserve the original state of those variables. So I'll just go through and I'll write that one out too. We'll just spend some time. We'll do that. Gotta go back through here, change all my X's back to I's. We'll take all this down. Set X equal to our upper bound, so Y. And we need to say I is greater than or equal to X. Decrement that instead. And in between, we will just print a couple new lines to space things out a little bit. So we can see that that doesn't do what I want it to do necessarily. I didn't change something somewhere. Instead of setting this X equal to, or this I equal to X, I accidentally set it equal to 0. So that needed to be initialized to X for this to work correctly. And there we go. So if we wanted to do something like this, where we needed to preserve the input, where we needed to recognize what X and Y was for both of these loops, we need to use that intermediary variable that we're manipulating. But if we're only using the input one time, we can just use the same variable that we read into as our index for our loop. So just remember, you can leave this off if you wanted to. You could leave this off if you wanted to. And you could leave this off if you wanted to. And you get a for loop that looks something like this. And that would be running forever because there's no condition, there's nothing to test to see if it would ever exit. But we'll talk about some different ways we can either get around that or complement that today. So we can also do multiple initializations, conditions, or increments. So let's say we wanted to do multiple initializations. Let's say we wanted to do something like, this doesn't really match this problem anymore, but we'll do it anyway. Let's say we wanted to initialize both I and X. We could say I equal to X, and then X equal to 0, or something like that. Or we could say I equal to X, X equals to Y, or we could specify any number of conditions that we wanted, or assignments that we wanted run that very first time the for loop is entered right here. And we just have to specify or separate those with commas. So just something to keep in mind. If you do need to initialize multiple things when you're starting out with your for loop, you can do that. Just say comma, and then the thing you want to initialize. So I equals to Y, or that wouldn't really do anything. It would assign it once here, and then it would obviously assign it once here, and it would overwrite it. So let's do like X equal to Y or something like that. But that's something that's completely valid. You could do that. So, and then you can also do multiple increment steps as well. So normally we would say plus plus I, but you could also say like plus plus I, comma, plus plus X if you had multiple variables you're manipulating inside your statement. Or let's say we had something like this. This is actually a good example here. I'll run through this one. So what we're going to do is we're going to have a for loop which prints, we'll say I is less than 20. It will print I every 1, and it will print X every 2. So we'll also start we'll initialize I to 0, we'll initialize X to 0 as well. And we're only going to test to see if our condition is I is less than 20, but we're also going to increment X every time we run the loop. We're going to increment, or we're going to add 2 to X, I should say, when we're only going to increment I by 1. So let's go back over here. We'll say I is this, x is this, and then we'll say we'll provide x to our printf. So we can see if we had a loop like this where we wanted something to grow at a certain rate and we wanted something to grow at another rate, we can totally do that. So you can compare the growth just like that, where we have one variable that's obviously being incremented by 1 and another variable that's being incremented by 2. So if you need multiple variables to keep track of certain things during your loop, if you need to do lots of complex things inside your loop, you might be ending up doing things like this. The other thing that we could do is, let's say we wanted to start one variable at 0 and start one variable at 19. So let's do x equals 19. Well, for this example, let's change that. I'll do 20 just so all our numbers look the same. We need to change that to I is less than or equal to 20. And then we'll change this x plus equals 2 to minus minus x. So we can see now we have I is starting at 0, x is starting at 20, and they go kind of like that, and they go backwards. So there's a lot of things we'll need to do, or a lot of problems that have solutions that look something like this, where it's not necessarily required that you do multiple initializations or multiple things like that inside of your for loop, but just keep in mind that if you want to do anything like this, that is completely within your power. So, and then finally, we can do multiple comparisons, and we do multiple comparisons in for loops just like we do in if statements. So we don't do like a comma or anything between it like that. We use our logical operators between our conditions. So right now, this works just fine, but just to show people how the problem should work a little bit better, we could say and x is greater than or equal to 0. And we could specify another condition right there. Just like before, we can do or to say if either of these conditions are true, then the entire condition will be true. So if this is true right here, or if this is true right here, then we're going to execute this for statement another time. Again, if we did an and, it would require that both the left-hand condition right here and the right-hand condition right over here are both true. So just applying these, again, we call these logical operators. So in our logical operators, again, we have and, we have or, and we have not as well, which can't be used like this, but if we wanted to, again, negate this match, so we could say, take the exact opposite of I is less than 20 and make that the truth value, then that would be how we could do it. So that's multiple initializations, conditions, and increments. So this is something that happens quite a bit is as people end up putting a semicolon at the end of their loop statement. We talked about this a little bit with if statements, but let's see what will happen if we have a semicolon at the end of our for statement. So recall when we compiled this before, this is what happens. This is the normal output we should expect when this for loop is run. But when we recompile it and run it again, we only get one line, and it kind of is off-putting. You look in your code and you're like, well, this looks perfectly fine. This is perfectly correct. But one of the things that we can actually do with a for loop is we can completely omit this component. That component is completely optional for a for loop. If we do have the semicolon at the end of our for statement, that means we're not going to execute any of the block of code below. So it's also worth noting, I'm pretty sure I noted this before, but we can have arbitrary blocks of code throughout our other blocks of code. These brackets and nested statements inside those brackets don't necessarily have to have any if statement or for statement attached to them. Normally they would. There's really no cases in which they wouldn't, but it is completely valid code to say that. So if you do have something like this where you have a for statement and it's executing only one time like this and it's giving you the final result that you would expect, it's certainly good to make sure you don't have a semicolon at the end of your for statement. Same thing applies to if statements. If you have a semicolon at the end of an if statement, so you say something like this, and I'll just comment this out. You say if, we'll just say true, or we'll say true, yeah. And you have like a semicolon right there. It will still, this code will still be perfectly fine. It'll compile perfectly fine. But of course it will, well, I guess this will always execute here, if false. So this shouldn't theoretically never execute if we're testing this condition. We're testing to see if false is false, and obviously it is, so this is never going to run if we don't have the semicolon here. But we put the semicolon there, and this will always work. So remember, in order to actually use the true and false, we need to say std bool there's some uninitialized variable warnings. We can see that that statement does execute, even though it looks like from casually reading over this code that that would work, but it doesn't. Or it should never execute, obviously, since that's false. So if we run it again, if we compile it again, obviously it shouldn't run because false is always false. So just always check to make sure you don't have a semicolon at the end of your for statement. Now, that's not to say that that functionality isn't worth anything. Let's say we wanted to do these operations and we didn't want to output any code based on it. Let's say we wanted to increment I by 5s or something like that. We just needed to increment it by 100 5s. Now, obviously, there's easier ways to do that. Let's say I equals 5 times 100 or something like that. But there's certain cases where you need to do something a certain number of times. You can just use a for statement with a semicolon at the end. So that is completely valid code. And if you read other code, you might see that every once in a while. It's kind of interesting the way people manipulate C to get the language to do the things that they want it to do. So, yeah. So this would be the code execution with the semicolon at the end. So you just completely drop this third step, which is execute the block of code. So pretty straightforward, I think. So one of the things we talked about was, let's say we had a for statement like this. We had for, and then like that. So a lot of people would read this as forever. Since there's no condition, there's nothing to ever exit from this for loop. But one of the things we can actually do is inside the body of a for loop, we can say break. And what break will do is it will immediately exit out of the for loop. So let's go and let's do our, we will go from I to x, and we'll just set x equal to 10 to start off with here. So we'll say I equals 0, I is less than x plus I. And we will print that off. So run that again, see where we're at. So 0 through 9 as expected. So let's say we put a break statement right here. What that's going to do is as soon as the for loop sees that break statement, it's immediately going to exit, regardless of what this condition is, regardless of what increment is being done. It will ignore all the other steps of wherever we're at in the for loop, and it will immediately continue executing right down here. So run it one time here. You can see that it does, the for loop does run the first time, but again, after it sees that, as soon as it sees that break statement, it immediately exits. So we can change it up a little bit. Let's say we never want to go past 5 or something like that. So let's say if x is equal to 5, we are going to break. So again, regardless of what condition we specify here, if we specify a break inside of our for loop, we are going to unconditionally exit from that for loop, ignoring the increment and anything like that. we can see that we did get all the way up to 5 here. Because the last time we came through, we incremented this. Let's say we came through here, I was equal to 4. So we came through here, we printed 4, tested to see if 4 was equal to 5. It wasn't, so we continued on. We incremented one more time, got to 5. 5 was still less than 10, so we printed it one time. Then we tested it, and 5 was equal to 5, and then we broke out of our for loop. So that's one of the statements that we can use. So you can immediately jump to step 6. So we immediately continue executing after the block of code, regardless of what's going on. And then we have the continue statement after that. So there's two different statements that we can use inside a for loop. We can use break and we can use continue. So what continue does is instead of exiting immediately, we jump immediately to step 4. So step 4 is increment the index. So let's say we wanted to, so we'll need to move this around a little bit. But let's say we wanted to do this and just skip 5. So we'll run this really quick here. So we can see that this lists 0, 1, 2, 3, 4, but we skip 5. So again, whenever we see this continue statement inside of our for loop, we are going to immediately stop executing the block of code and go on to our step 4, which is increment the index. And then we continue to test the condition and start the block of code back from the top. So if we did something like this and we put it down here, that wouldn't have any value because we're going to continue executing the increment statement regardless. It doesn't matter that that continues down there. You could still have it, it just wouldn't do anything. We'll show you that. So 4, 5, 6, 7, 8, 9. So it doesn't really have any impact at that point. But let's go back and let's change where we're doing our break. So remember we had our break here before. So that would give the opportunity for this printf to be run while I was equal to 5 at least once. But I'll show you that one more time. So we do print out 5 that very last time. But let's say we wanted to skip 5 entirely. We can move that statement out. We can put it right here. And now 5 would be skipped entirely because we break before we have the opportunity to run that printf. So two different ways that you can, or two different statements that you can use to manipulate for loops. You can use break to immediately exit, or you can use continue to start with the next iteration and ignore everything that has happened. So, or ignore all of the remaining lines of code inside this. So, let's do this. We'll say, before here, say, I is really I. So we'll print out, regardless of what happens, every single time that what I is really. And then it finally will print out I want the I want you to see. And I'm going to leave it like that so I can, whatever. So let's say we only wanted to print even i's. So we test to see if I mod 2 equals 0, if it is even, or let's test this. If it's not even, so not, the remainder is not equal to 0, we will continue. So if I is even, this will be ignored, and we will print this final statement. So we can see 0, that was even. 1 wasn't even, so we continued. We skipped the second statement. And then so on and so forth all the way down, because we skipped the I want you to see on all of the odd numbers. So let's say you want to do something like, obviously there's easier ways to do this, but this is a good example. Let's say you wanted to sum all of the even numbers or something like that. You could say and sum equals 0. And then sum plus equals I. Obviously, again, there's much easier ways to do this, but it's kind of an example of how the code would run. But you can see that all of the odd numbers would be skipped and all of the even numbers would still be processed. So if you needed to skip certain numbers but continue executing numbers, processing numbers afterwards, you use continue. If you see something that you want to immediately exit out of, you can use break. So those are two statements you can use to control the execution of your for loop with more detail. So continue statement jumps to 4, break statement jumps to 6. So this is the main thing that you'll need to know for assignment 4, I believe. The one dealing with printing out the different shapes, doing some sum stuff, printing some ranges. It's nested for loops. So the main thing, again, that you need to know is that you can put for loops inside for loops, and you can put if statements inside for loops, and vice versa, back and forth, forever and ever. And it just works like this. So every time this outer for loop runs once, so let's go back here. Every time step 3 runs here, all of the other steps run for the nested for loop. So for every single time that this outer for loop runs once, this for loop runs all of the times it possibly can run, and then it continues on. So realistically, the best way for me to show you this is just do an example. We're going to count to 10 n number of times. I should have done it the other way, whatever. So for this, we're going to need 2 index variables. We need int I, int j, and then finally the integer that we're going to read into the limit. So we will say scanf. We will read in, and we'll say for I equal to 0, I is less than n, increment I, and then start out our body. We'll come back and we'll look at that more. So in our inner for loop, what we need to say is j equal to 0. J is less than, we'll say less than or equal to 10, and we will increment j. So inside here, what we're going to say is printf %i space. We'll see why we need this space later. And then say j. And then after this for loop has been executed, we will print off a new line. And we'll come back through here and I'll try and explain what's happening on every single step of the for loop so you can really understand why this is necessary. So we'll say 10. So when you put in 10, it's going to print 0 through 10 to the screen 10 times. Let's say you put it in 1 time. Print it once, 5 times, or print 5 times. So let's kind of examine why this is happening. So I'll put a print statement here, entering outer loop. This is going to break things really badly, but that's fine. And we'll say exiting outer loop. So we can see that every single row right here is one iteration of the inner loop. So every time that we enter, so this enter the outer loop and exiting the outer loop are executing both right here and right here. So just as a little bit more detail, let's show what I is. I is that, and then we'll substitute the value specified here for that %i. So you can see I is 0, 1, 2, 3, 4. So for every iteration of the outer loop, I is being incremented by 1. That's counting the number of times we're running the inner loop. So when we're running this inner loop, so this is representing what the j values are. So j is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then again, just by the nature of the for loops, that for loop is going to run until the condition is true, and so on and so forth. So change this up a little bit. Let's do this. Instead of printing with spaces, let's print with new lines. And I will show you, we'll say I is this, j is that. So we'll specify I there, j there. Yeah, that's fine for now. We'll do it with something smaller like 4. So we can see that each one of these lines here is produced by one iteration of the inner loop. Now we can tell, so again, the I is counting the number of times, so the outer loop is all it's doing is counting the number of times that the inner loop runs. So this is a really good example of, this is one iteration of the outer loop right here, and this right here is one iteration of the inner loop. And these are all the iterations of the inner loop, and these are all the iterations of the outer loop. Alright, so let's go back through here. I'm going to change this up a little bit. One of the things that's super important, if you have looked at the pseudocode at all for assignment 4, you've seen that one of the things I say is, or I reference in the pseudocode I should say, is inner index or outer index or things like that. Now when I'm referring to something like the outer index, let's say we're right here, the outer index in this case would be I. So I is outer index, because it's the index of the surrounding for loop. And then you could say something like j is the inner index, because it's the index of the farthest inward loop. Or you could say something like the current index, or you could say just index, because that's the index in this context. But just like I'm doing here in this print statement, I can reference the outer index at any time, so I can always see what I is when we're doing things with j, when we're doing anything like that. So let's go ahead and look at this example. So right now we're printing 0 through 10, however many times the user specifies. Or am I going to give you that as an in-class assignment? Yeah, I'm going to give that as an in-class assignment. Okay. So just remember that you can reference the outer index. So maybe do something like manipulate the condition right here to reference the outer index instead of the inner index, or a static number, or a number that's read into the user or something, read in by the user. This can reference any variables that you want it to. It doesn't just necessarily have to be static like this comparison. So let me check. Yeah, so we're going to work on that as an in-class assignment. So you can kind of start from where I started right here. You have this example, or I've shown you this example, I should say, that will go from, it'll print 0 through 10 n number of times. Now what I want you to do is change that a little bit, and instead of saying, let's say we said for this input 3, instead of saying 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 3 times, what I want you to do is say 0, 0, 1, 0, 1, 2, 0, 1, 2, 3, based on the input from the user of 3. Now, the most important thing you need to remember here is that you need to reference the index of the surrounding or outer for loop for that to work. So in your condition statement right here, in this right here, you need to change that to reference the outer index. So that's all I have for you today. Let's let's get started on that. Feel free to ask me any questions. Otherwise, do remember midterm week from today, and assignment 4 is also due a week from today. So definitely get started working on assignment 4. Definitely review those things on D2L about the midterm concepts. Again, any questions, feel free to ask.